Hey guys, hope you guys are doing well. This is Minjay and Donghao, and today we're going to present the contents of Chapter 9, Identity and Change. So, logic deals with the issues of identity and change quite often, and these mostly have to do with how to identify and how to track objects and their properties over time. Without further ado, let's get started with identity. So, what is identity? This is basically the relation that states that every object has to be self and nothing else, and it is expressed by the symbol equal sign and the word is. Here we've got to be careful because there are two kinds of word is. Um, one is being used for predication and the other one is being used for identity. We'll take a look at some examples here. Firstly, this example, the sentence, your hair is black. So what it does is that this sentence is basically stating that property, in this case, your hair, having an attribution of being black. So the term is being used for predication here. On this sentence, my name is Benjay. It is pretty straightforward. The term is being used for identity. It's basically stating my identity. This sentence is that's what it's about. Let's move on to relation. So what relation does in logic is they connect two objects. We'll take a look at some examples from the book with this matter. Um, so firstly, John sees Mary. In this case, seeing is a relation. Therefore, the sentence is basically stating the relationship between two objects, John and Mary. However, on the other hand, John sees himself. This sentence states the relation that John bears to John, and this is rather odd. And but what it basically means is that it's the sentence is basically a form of identity. I don't know if you guys remember about what I said about identity previously, but Graham Priest basically states that identity is a relation that every object bears to itself and nothing else. So if this sentence is stating the relation that John bears to John, so this sentence is a great example of identity. Okay, so we have a bit of a different example here. Let's slowly read out the sentences from the first one. Okay, so first, John is the person who won the race. Second, the person who won the race got a prize. Third, so John got a prize. You guys might be wondering what this these sentences are all about. Well, these sentences are a great example of Leibniz law. And my apologies in advance if I mispronounced the guy's name. It's German. So John is the person who won the race. So here the term is in this statement is emphasizing the identity of John. John is the person who won the race. So when you look at the second sentence, the person who won the race got a prize. So we can we can tell that John and the person are same objects. And what Leibniz law basically tells us is that if two objects are the same, any property of one is also the other's property, and vice versa. For this reason, John gets a prize because John and the person are the same object. So Leibniz law is quite a useful tool for reasoning about identity, but it also has some apparent counterexamples, such as cases involving descriptions, parts, and change.
So, to help us further understand the Leibniz law, Priest also gave another example. So this is a road. It's both a dirt road and atomic road. According to Leibniz's law, if two objects are the same, any property of one is a property of the other. However, you might also wonder, how can a road be dirt and tarmac together? And what has gone wrong here? What has gone wrong is the specialization of the properties are not precise enough. We are not being precise enough in our specification of property. And in this case is the road is being tarmac at such and such a point, and being dirt at such and such a point. Since they are the same road, they have both properties. Therefore, this case does not violate Leibniz's law. The formula below is more a precise version to understand Leibniz's law. As you can see, there is a G added, which refers to it is always going to be the case that. So to interpret this formula, it will be the premise x equals to y, and it is always the case that x equals to x. Therefore, it is always the case that x equals to y. Regardless of time, it is true now, true at all times, in the future, and in the past. So the last section of this chapter is about change, and Priest gave the case of a mobis and its change. So a mobi is a one-celled creature. It will split down into middle to become two amobis. And in this case, amobi A divides to become amobi B and C. Before the split, both B and C were A. So we can say B equals to C. After split, though, B and C are distinct amobis. B therefore unequals to C. If two things are the same, it does not necessarily follow them. They are always going to be the same, according to this case. And we can also state that B is A, because B is not a new amobi. It is still simply A, which means they share the same identity. We do not need to consider C, because the identity of something cannot be affected by whether there are other things around. Vice versa, we can also state that C is A. So to recap the content of this presentation, we have the two definitions of is, which represents identity and property respectively. Like, my name is Alec and my hair is black. We also have relation, the definition of relation, and Leibniz's law, that if two objects are the same, any property of one is the property of the other. I think that's the most important one. And then we have change. I hope you will have a good performance of the quiz, and thanks for listening.